Okay, welcome back. This is the rational roots theorem, which is another tool for us to be able to find the roots or the zeros of polynomial functions. This is a theorem that is kind of difficult to explain and probably won't make sense when I explain it here, but you will see that it's actually pretty easy to use as you go forward to use it in problems. So it's easier to use than it is to necessarily understand the words or the description of the theorem. But I'm going to have to explain that to you anyway to be a responsible math teacher. So the rational roots theorem says that for any polynomial that has the form like this, p of x is our function, equals s times x to the n plus whatever's in the middle. Whatever's in the middle isn't important for the rational roots theorem. Plus t, so I have a leading coefficient. This is a leading coefficient, so s is my coefficient, t is my last number, so it would be like x squared. In that case, s would be 1 plus 3, and t would be 3. So that's basically what that means. So you'll see it in action. The rational roots theorem lets us create a possible, or lets us figure out what the possible rational roots. So remember, possible. It doesn't say that they are the roots. It says that this list that we're going to be able to create is the possible rational roots. And those rational roots have the form of b over a, where a is any factor of s, and b is any integer factor of s, and b is any integer factor of t. So you're probably thinking, Mister, I don't know what to do. This doesn't make any sense. So I'm going to walk through a problem because it'll make a lot more sense once we do that. So let's look over here. So I have 3 polynomials here. And we're going to create the list of possible rational roots for each one of them. And then you'll see, oh, this isn't so bad. So I want to start off by looking at this one. So I need to find my s and my t in this one. So in this case, my x is the biggest term, so it's the leading term. So my coefficient here is really just 1. And then my t, so let's just write it out here. My s equals 1. T is my last term, my last number term, equals 10. So I have my s and my t. That helps me, but it doesn't give me everything. So I need to first find a. I need to find all the possible integer factors of s, and then all the possible integer factors of t. So basically, we're going to throw it back a little bit. So the possible integer factors of s are, we could do 1 times 1. So 1 is a factor of s. And we can do -1 times -1. So really, I just have 1 and -1 are the possible integer factors of s. So these are going to be my a's. So a could be one of those things. For t now, for 10, my possible factors, integer factors of 10 are 1 and 10. And we can do negatives and positives. So my b could be equal to positive -1. It could be 2 goes into 10, positive -2. 2 multiplied with 5, so I could have positive or -5. And then to complete what we're doing, positive and -10 is also an integer factor of t. So now I have my list of things that I could have here. So now I know that the list of possible rational roots are of the form b over a. So that means it can be any combinations of these. So I want to look at my list here. So I know that b over a, so it could be positive or -1 over 1. Because any combination of these will give me positive or negative. So this is just positive or -1. It could be positive -2 over 1, so it could be plus or minus 2. It could be plus or minus 5 over 1, which is going to just give me 5. And then if you do the same thing, it should be positive -10. So the rational roots theorem tells us that these are the possible rational roots of this equation. you should be able to tell me pretty easily what the root is of this equation. As you can see, we're looking for the x value that gives us 0 if we plug it in. So that should be pretty easy to see that x should be negative 10. So x equals negative 10 is our root. And you can see over here that it gives us the possible list, and right here, this negative 10 is on the list, which is what we want. So that is one example of how we would do this. So we'll move on to this next one here. So in this case, I have s equals 2. That's my leading coefficient. So s equals 2. My t equals 3. This will be a little bit of a shorter list. So I have s, and I have a. So it could be, my factors of 2 could be positive or negative 1, or positive or negative 2. Okay, so that's a relatively short list there. For t, my b values could be either positive or negative 1, or positive or negative 3. Okay, so I'm going to actually have a shorter list now for this one. So my possible, so it has to be in the form of b over a, remember. So my possible list could be plus minus 1 over plus minus 1, which will just give us, overall, this will just be plus or minus 1. Plus or minus 1. It could be plus or minus 3 over 1, which is just 3. Now I have to go back to, so I've done all my combinations of b's with the same a, so now I need to do it with the second a here, so it could be plus or minus 1 over 2. 1 over 2. Or it could be plus or minus 3 over 2. Okay? So these are my possible rational roots. Here's my list of all the possible rational roots of this function. If you wanted to, you would be able to check on a calculator to see which one it is. You can also plug each, if you are completely not sure, so this one was easy for us to see that it should have been negative 10. You can also, if you are not sure which one of these would make the most sense to use in here, you can just plug each one of these in to make and do basically guess and check. Okay? So this is a possible list of rational roots for these two functions. Now we'll do one last one. So I need to find my s and my t again. So in this case, my s is my coefficient of the leading term, and my t is the 7, which is the last non-x term value. And you'll notice that we actually don't even care about what's going on here. These don't tell us anything useful for this theorem. Okay? So my s equals 5. This looks like the same thing. It's s equals 5. And my t equals 7. Okay? So now I'm going to do the same thing over again. I have my possible factors of s are going to be, a could be plus or minus 1, or plus or minus 5. T, the possible factors of t are plus or minus 1, plus or minus 7. So that means that the possible rational roots for this function, the possible ones, not all of them, this doesn't tell us the rational roots, it just tells us the possible ones, are going to be plus or minus 1 over 1, which is 1, plus or minus 7 over 1, which is plus or minus 7, plus or minus 1 over 5, and then plus or minus 7 over 5. So when it asks you to apply the rational roots theorem to create a list of possible rational roots, what you were doing is you were looking at the leading coefficient and the ending coefficient. You are going to find the integer factors of these two numbers, and then you're going to, in the form b over a, you're going to create this list of possible factors. Just so you know, all of them should be plus or minus, basically. So it could be the positive or the negative root for each one of these. Okay? So hopefully when you are doing the practice problems, this is a little bit easier for you than what it may have appeared just by reading this. If you have any questions, let me know, but this is going to be another tool to help you be able to find all the roots of a polynomial function.